بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today is about relative positions. Now we need to find the sign of a function, and let's see it graphically. F is a function defined graphically by its representative curve C. We can state that f of x is greater than 0 if and only if C is above the x-axis, because C is the representative curve of f and the x-axis is the representative curve of y equals 0. And f of x is less than 0 if and only if C is below the x-axis, and f of x equals 0 if and only if C cuts the x-axis. So it's similar to the relative positions of two curves, but here we have a curve and the x-axis. Application: C is the representative curve of f, and then we need to solve graphically each of the inequalities below. Now I want you to solve f of x is greater than 0 in this specific figure. Take your time, compare it to the given answer. Now f of x is greater than 0 when C is above the x-axis, and we can see it graphically that C is above the x-axis when x belongs to minus infinity minus 1 union 1 plus infinity. Let's see another example. We need now f of x to be greater than or equal to 0 in this specific figure. Again, take your time. Now f of x is greater than or equal to 0 when C is above or cuts the x-axis, and in fact C is above the x-axis or cuts the x-axis from 1 close to plus infinity. Now a third application, we need f of x to be less than 0 in this specific case. Take your time, compare your answer. Now f of x is less than 0 when C is below the x-axis, and in fact here there is no solution because C is always above the x-axis. We need f of x to be less than or equal to 0 in this specific case. Again, take your time. Now f of x is less than or equal to 0 when C is below or cuts the x-axis, and in fact C is always below the x-axis for any x. So in this case the solution is x belongs to R. Now let's see the sign of a function tabularly. Now f is a function defined by its table of variations. We can say that f of x is greater than 0 if and only if its minimum is 0, and f of x is less than 0 if and only if its maximum is 0. Let's see this example. We have this table of variations. It's a table that represents a function f. The question is, use the table to study the sign of f of x. Now remember, this is f of x and we need to study its sign. Now we see from here that the sign of f of x varies from one interval to another. For example, f of x here varies from negative infinity to negative 2 and then from negative 2 to negative infinity. So we can say that f of x in this region is negative. Now here it varies from positive infinity to 0, then from 0 to negative 4, and then from negative 4 to 0. So here it's sometimes positive and sometimes negative, and it's sometimes 0. Remember, we are using the table of variations to study the sign of f of x, and this is f of x. For x belongs to negative infinity 0. So from here to here, we just look at f of x and see whether it's negative or positive. Now f of x in this case, you see it is increasing, but it's negative because it varies from negative infinity to negative 2. So here I say that f of x is less than 0 because its maximum is negative 2. So on this interval specifically, the maximum of f of x is negative 2. And if the maximum of something is negative 2, means that this thing is less than 0. Now on the interval 0, 1, this is from 0 to 1. F of x varies from negative 2 to negative infinity. It's also negative because its maximum in this case is negative 2. When the function varies between the two numbers, negative 2 and negative infinity, means that its maximum in this case is negative 2. On the interval 1, 2, this is 1, 2. Now I can see that f of x decreases from plus infinity to 0, but it is, in all of these cases, a positive quantity. So we can say that f of x is positive since its minimum is greater than 0. And the minimum in this case is slightly greater than 0. For x equals exactly 2, when x is exactly 2, we can say that f of x is exactly 0. X belongs to the interval 2, 3. F of x varies, it decreases from 0 to negative 4, so it's negative. And in order to justify that it's negative, I have to use the word maximum. So I say that f of x is less than 0 because its maximum is less than 0. You see, in this specific interval, the maximum of f is 0. And finally, on the interval 3, positive infinity means here in this region. Now we see that f of x increases from negative 4 to 0. So its maximum in this case is less than 0, so it's negative. Now we can simplify this verbal discussion by a very nice table here. So from minus infinity to 1, simply you just look at f of x and you see that it varies from negative infinity to negative 2, then to negative infinity. So it's simply negative. You can say that it's negative. And from 1 to 2, this is 1 to 2, it is positive. And from 2 to plus infinity, it's negative. What is the justification? From minus infinity to 1, you see its maximum is negative 2, and if the maximum of something is negative 2 means that it is negative. And from 1 to 2, its minimum is greater than 0, and here its maximum is less than 0. Now let's take another example. Each of the given tables below is the table of variations of a function f. Use each table to study the sign of f of x. This is a table and we need to study the sign of f of x. Now try to take your time. It's an easy part, pay attention. Now f of x is positive because its minimum is 2 and 2 is greater than 0. Remember, we look at f of x. Now it varies from positive infinity to positive 2, then from positive 2 to positive infinity, so it's always positive. We can express it also using a table in this form. Let's see another example. This is a table and we need to study the sign of f of x. Take your time. On the interval negative infinity, negative 1, we can see that f of x is positive because its minimum is greater than 0. And on the interval negative 1 plus infinity, it's negative because it varies from 0 to negative infinity. So its maximum is less than 0. And when x is exactly negative 1, f of x would be 0. And this could be also expressed using a table. So from negative infinity to negative 1, it's positive. And from negative 1 to positive infinity, it's negative. Now, Mira or Amir, we have a function f, c is its curve, and we need to study the relative positions of c and l, where l is the line with equation y equals negative 4. Thank you.